sheet with the name phonetically spelled for me, as if I haven't known George Villacris long enough to learn how to say his name. But I have known George since he was a testing engineer in District 5 over at Newark. George is now a part-time consultant and specializes in asphalt pavements. And he was with the Asphalt Institute until June of '98 for 12 years. Served Ohio, Kentucky, and West Virginia. Prior to that was when I knew him with the ODOT, and he was with ODOT for 32 years. All in Newark, all in Newark. You were there when they paved the first road in,
Just about.
First road in out of Newark. He was a design engineer, construction project engineer, and then for the last 23 years is the testing engineer. Graduate of Catholic University of America in Washington, D.C., where he received a bachelor's degree in civil engineering in 1954. Been a licensed engineer in Ohio since 1960. And your son was in the Pentagon last week.
Near the Pentagon.
Near the Pentagon. He's
Fine.
okay, George Phillips. Same rules apply today. Get up and leave if you need to. Get up, stand up, get drowsy. Get up and leave until you come back. Don't all go at once. Just because there's a race this afternoon, nobody from Delaware leaves the room at any time during the day without permission.
We need to have Tate turn this on.
Tate, turn this on. Where's our highly skilled technician? Emergency call.
And should I do the lights? Which other ones should we dim down? Can you see that all right? All right. Thank you very much, Joe, for that wonderful introduction. I think you made part of it up, though, to make it look like I'm older than you are. But both of us have been around for a long time. I first met Joe back in the 1960s when he was working for a paving contractor, and I've known him for quite a few years now, and makes me feel kind of old. I know he hasn't gotten any older, only I have. I'd like to introduce Wayne Jones, the Asphalt Institute District Engineer, who's here today, and he has his business card back there and some catalogs, and there are some Asphalt Institute manuals. I'm not promoting the Asphalt Institute anymore because I'm retired from there, but I just wanted you to know that they are there. I had a couple of manuals left over from when I was with the Asphalt Institute.
I'd like to take the opportunity to thank you for the opportunity to be with you this morning, to let you know that I'm new with the Institute. George was one of my predecessors. The previous predecessor took the office over to West Lafayette. I'm sure you'll all be glad to know that we brought back to Columbus now. I've reestablished it here on the east side of Columbus. My business card is back there. If you have any asphalt-related questions, don't hesitate to give me a call. Just a bit of editorializing that I heard yesterday. I'd like to respond to it. We think the white product is a good material for bridges and curbs and gutters, and that asphalt is a pretty good material to build pavements out of.
Notice how the lights blink when you sit there. I didn't do it.
Is that a little bit better for the for that? Still, these lights up here are shining on it. Did you have those off yesterday, Joe?
Yeah, I don't think those overheads. Let's see if I can.
That's
George, you want to be able to see the audience's eyeballs.
yeah, I know.
There you go. That's
Now we're talking. How about for the TV? Is that still okay? For the videotaping?
whatever you do.
Okay. All right. Today we're going to talk a little bit about pavement preservation with asphalt pavements. I have a good bit of information for the next hour and a half. The good thing about this presentation is at the end of it, you'll have a break. So you can look forward to the break at the end of this time. We're going to talk a little bit about things that you've already heard about, a couple of review things, and then we're going to get into some new information that you haven't had yet. Here are some issues for consideration. What is pavement preservation? We really haven't talked about that term a whole lot, and we'll look at it here during this discussion. And how does it differ from pavement preventive maintenance, which is mostly what we've talked about? When should these be applied? Is preventive maintenance effective? And if so, why isn't everyone doing it? There are a few terms that we're going to define. These are pretty much the Federal Highway Administration and AASHTO definitions of these terms. We're going to define routine or corrective maintenance, preventive maintenance, pavement rehabilitation, pavement preservation, and pavement reconstruction. First of all, routine maintenance. It's reactive in nature, not planned. You react to something that's gone wrong in routine maintenance. It's performed to correct deficiencies on pavements that are distressed, fix a pothole, or some other defect in the pavement. This type of maintenance usually doesn't contribute to long-term performance. It just fixes the problem at the time, doesn't help the long life of the pavement. It's often performed under harsh conditions. Those of you that work for an agency know that. It's often done in the rain or in the cold or under some other trying conditions. And quite often the repairs perform poorly, particularly if they're done quickly and under harsh conditions. That's what we call routine maintenance, sometimes called corrective maintenance, sometimes called reactive maintenance. Preventive maintenance, on the other hand, is a little bit different. You've already seen a definition of this. This is in the way of review. This is the planned strategy, and there's some key words in here that we should remember. It's a planned strategy. It's cost-effective treatments to the existing roadway system and its appurtenances. It preserves the system, it retards future deterioration, and maintains or improves the functional condition. It does not increase the structural capacity. We're not talking about making a pavement stronger when we do preventive maintenance. This is the AASHTO Standing Committee's definition of preventive maintenance. There are several other definitions, and you'll probably see some others even in the literature that you have, but this is the one that AASHTO has come out with. Pavement rehabilitation. This term is bandied around somewhat, and let's take a look at it. This restores the serviceability of an existing pavement, pretty much what preventive maintenance does, but maybe a little bit stronger. Maybe the pavement's in worse shape when you do pavement rehabilitation. It extends the service life of the existing facility. Very similar again to what preventive maintenance does. It may include milling and or surface recycling. Again, preventive maintenance could do that also, so there's some similarities here. And it can include the placing of a surface course or multiple courses. And it could include other work, such as drainage or patching, etc. It returns the pavements and the shoulders to a condition of structural or functional adequacy. So this is what pavement rehabilitation is. One more thing to remember, it's more extensive than preventive maintenance normally. All right? And if you are looking for terminology and things, in your handouts you have all of these slides. If you'll take a look in your folder, every one of these slides is in your handout. If you miss any of these, you can look in there and follow along. Now let's take a look at the next term, pavement preservation. This is the title of our short course, Pavement Preservation, and we want to know how this ties into the others. So let's take a look at this, definition-wise. It may not mean a whole lot when you're out there working on the road, but if you're reading literature, collecting information, it's a good idea to have an idea of what these terms mean, as defined by the Federal Highway Administration and by AASHTO. Pavement preservation is the sum of all the activities undertaken to provide and maintain serviceable roadways. Kind of a generic term, but it means taking care of your pavements in general. It includes the following things. Routine or corrective maintenance is part of pavement preservation. Preventive maintenance is part of pavement preservation. In fact, it's the bulk of it. It's the main component of pavement preservation. And it also includes minor pavement rehabilitation projects. It excludes the following: new construction or reconstruction, and any major pavement rehabilitation projects. So that's what pavement preservation is. How about pavement reconstruction? You see it's in a slightly different color. It should alert you to something. It's construction of the equivalent of a new pavement structure when you do it to an existing roadway. It usually involves the complete removal and the replacement of an existing pavement structure. It can include new materials, recycled materials, or possibly both. It is not a part of pavement preservation. Some thoughts on preventive maintenance, which is the key to the pavement preservation system. It's the whole foundation of the pavement preservation system. So when we talk about pavement preservation, we're primarily talking about having a good preventive maintenance program. Understanding preventive maintenance is essential if you want to get into pavement preservation. Joe required every one of us to show this graph. That's why I'm showing. This is about the third time you've seen this graph. So here it is. This one here looks a little cockeyed there because this was drawn on the computer, and it really wouldn't be quite that sharp. It'd be a little bit more slanted there, but the idea is the same. The concept here again is, this represents the condition of the pavement and this the age, and at zero age, when it's brand new, it's in good shape, and it starts deteriorating slowly at first, and your pavements, once they start deteriorating, they keep deteriorating faster and faster, and the whole concept again, small amount of money for preventive maintenance when the pavement's still in good shape will save you dollars because you won't have to spend it a short time later when the pavement's in real poor shape. The importance of preventive maintenance. In the past, maintenance has had what I call a variable role. It's been relegated to a very low priority in many cases. Some agencies make it a low priority. Some agencies don't do any maintenance at all or haven't in the past. But our focus now in general is no longer on new construction as much as it is on preserving the existing system. And preventive maintenance plays a very large part in that, and I'm sure all of you are aware of that. We can't afford to keep doing things the same way as we have in the past, such as worst first. And I hope all of you understand what we mean by worst first. Anybody like to give me a definition of what worst first means to you? What does worst first mean?
Throwing your money into your worst streets.
All right, fixing your worst streets, and it takes all your money, and in the long run, it's like being in a peat bog and trying to dig your way out, and you never get out, because all you're ever doing is fixing the bad streets, and you never are able to take care of anything else, because all your money goes into that. You never get a chance to preserve your system when it should be preserved. So getting out of that is a lot easier said than done. It's a difficult first step to take. Here's another slide that Joe required us to show. This is about the third time you've seen this one. Philosophy of preventive maintenance, the right treatment, the right pavement at the right time. Well, how do you know what the right treatment is? I hope that after these 2 days, we'll have a little bit of an idea of the different treatments that are available, and so that you can make a decision as to what the right treatment is. And the right pavement, we've already talked yesterday about how to select a pavement for preventive maintenance. And applying it at the right time is a decision that the agency has to make. A quick look at the benefits of a preventive maintenance program: higher customer satisfaction, better informed decisions on the part of the agency, improved strategies and techniques. You can expect those when you have a preventive maintenance program. Improved pavement condition, which is what we're really looking for. Cost savings. They're usually long-term, but you will have cost savings in the long run. And increased safety. First of all, let's look at customer satisfaction. A road exists to serve the traveling public. They're our customers, and those are the ones that we that should be serving. Smoother pavements and fewer traffic delays will increase customer satisfaction. Decisions should be made as much as possible to improve customer satisfaction. Several of the presenters yesterday talked about customer dissatisfaction. You always get calls from customers when they're dissatisfied, but those of you that work for an agency, you probably don't get too many calls saying, "Boy, you sure do have a nice pavement," do you? Any people get calls like that? Probably don't get too many. And a pavement preventive maintenance program should focus on customer satisfaction. But that is something that you should get out of a preventive maintenance program. You should be able to make better informed decisions also. The program relies on proper treatment selection and the proper timing of it. You should be able to do that better from the information that you get from putting on this program. Successful programs in preventive maintenance have very often been integrated with pavement management systems. And Joe Kindler talked to you yesterday about pavement management. Those two go hand in hand, because a lot of the information you need in preventive maintenance comes from a pavement management system. Continuous improvement of strategies and techniques. You develop new and improved treatments. When you have a system, you can correct deficiencies in your existing system by following the system, and you will probably be applying treatments while the pavement is still in good condition. That's the basis of a pavement preventive maintenance program. And it also minimizes traffic disruptions. You will get improved pavement condition, hopefully, from a preventive maintenance system. The overall condition of your network should improve. Cost savings. This is probably the best argument for having a preventive maintenance program. It's not something that comes immediately from the system. In fact, initially in implementing a preventive maintenance program, you have increased cost. You have to overcome that worst first problem. But in the long run, you will have cost savings. And there are different types of cost savings, less expensive treatments once you get the system going, longer pavement life. It will be long-term savings and reduction in user delay costs, which we haven't really talked a whole lot about. Delays to the customers, to the traveling public during their traveling. Some cost comparisons. One agency did cost comparisons on the difference between various actions. They figured that preventive maintenance for a particular function would cost them $10,270. If they rehabilitated that same area after it got in worse condition, it would cost $45,000 and some. If they had to reconstruct it, it would cost $574,000. This was the city of Bedford in Texas, and on a per lane mile basis. This is information that was gathered by AASHTO. Increased safety also is another benefit. Safety is a top priority with a lot of drivers. The explicit benefits are improved surface condition, fewer defects. The implicit benefits are a better pavement condition. Accidents hopefully will be reduced, and fewer and less disruptive repairs. Now let's take a look at what preventive maintenance actually includes when we're talking about asphalt pavements. Maintenance of drainage features can be part of it, and in fact it is. Crack filling and sealing, fog seals, slurry seals, microsurfacing, and chip seals. All of these are things that I'm not going to talk about. Some of them have already been talked about, and others will be covered later today. Today we're going to talk about cold-in-place recycling, hot-in-place recycling, milling or planing as it's referred to in the Ohio DOT, thin hot mix asphalt overlays, and a couple of newer technologies. These are the things that we'll talk about in the next few minutes. First of all, recycling. There's cold-in-place recycling and hot-in-place recycling. And what is the difference between the two? Can anybody tell me what the difference is between the two? Is one done in cold weather and the other one done in hot weather? No. How are they different? Rather obvious when you think about it, but in cold-in-place recycling, there's no heating of the pavement or of any of the mix. The only thing that's warm is the emulsion. In hot-in-place recycling, you heat the pavement, and you can use some hot mix along with it. So there's heat involved in the second option there. We'll talk about each of them. First, cold-in-place recycling. This is a process in which a portion of the existing asphalt concrete pavement is milled. Then that reclaimed asphalt pavement, the wrap, which is milled up, is normally sized and crushed if it has to be. It's mixed with a new binder, which is an asphalt emulsion normally. You can have an additive, which could be a rejuvenator, and sometimes virgin aggregate is mixed with it, but that aggregate is not heated. The remixed material then is placed back on the pavement once it has been fully mixed, and it's compacted and left to cure, and then usually a new wearing course or surface course is put on afterwards. Normally it's best to wait several weeks until that emulsion cures, and then a surface course is put on. It's pretty much necessary to put on a surface course. Sometimes cold-in-place recycling is left for the traffic to ride on, but usually it's not a completely satisfactory surface, and it's pretty necessary to put on a new another course, and that can be either a hot mix asphalt overlay, or it can be a chip seal or double chip seal or some other kind of treatment. There are a couple of construction options. There's a single machine process where just one machine goes over and does the entire cold-in-place recycling. Or you can have a single-pass equipment train where there are several pieces of equipment that do the work. The purpose of cold-in-place recycling is to improve the profile of the pavement, fix the crown or the slope of the pavement. It corrects surface distresses, and it usually reworks the asphalt concrete to a depth of about 2 to 4 inches. We've got some metric terms in there, and you can see the equation. 50 millimeters is 2 inches, 100 millimeters is 4 inches. So it doesn't go down real deep. It can go a little deeper, but normally it's in the area of 2 to 4 inches. It's mostly used on lower volume roadways, those that have less than 10,000 annual daily traffic, average daily traffic. Here's a diagram of a single pass machine. I don't know if you can see that real well, but it's in Technicolor so you can get a better idea. The machine is moving to the right. Here is the milling operation. It puts the material in here, it goes up here and goes into this sizing place where it's screened and sized, and anything that's the proper size falls on the conveyor belt and goes back this way. That which is too large goes into the crusher and then comes back onto the conveyor belt. All of that material, once it's the proper size, goes into the pug mill where the emulsion is added and then it's deposited on the pavement. So that's in general how it works. So there are variations on this, but that's in general how the operation works. Here's a single pass equipment train. It does a similar operation, but there's more than one piece of equipment. This one is moving to the left. The first thing you have here is what they call the pavement profiler that does the milling, and then that material then is deposited into the screen and crusher. That which is too large is crushed. Then after it's all sized, it goes into the pug mill where it's mixed with fixed by hot-in-place recycling. Low surface friction can be improved, and rutting can be repaired by hot-in-place recycling. There are several hot-in-place recycling techniques available. The earliest and probably the simplest one is heater scarification. Another one is called repaving, and another one is called remixing. Those are the three that we'll look at. There may be other combinations available. Technology is changing and improving all the time. Heater scarification. The simplest one again. In this diagram we have a preheating unit. This is the radiant heater that heats the pavement. And in this case the scarifying teeth are not used. All this first piece of equipment does is heat the pavement. Then the second unit comes along and it also heats the pavement, has scarifying teeth here that dig down into the pavement 1 inch or 2 inches, whatever the project calls for. And then there's an auger that distributes this evenly across the pavement, and a spray bar. Well, first of all, the spray bar puts the rejuvenating agent in with it before it's distributed across the pavement, and then the material goes under the screed and is spread out on the pavement. And again, in this case, this is normally not a surface course. This is normally an intermediate course, and you'll usually want to put something on top of it. It will be a mixture of the wrap along with an asphalt emulsion, and it's usually not the quality that you want for a surface course. This is a photograph of a heater scarifier, and it's kind of difficult to see here, but there should be a system here for spraying the emulsion and a screed there for the an auger and a screed for the material to be distributed across the pavement and to be spread out on the pavement. But you can see the rest of this. That's the heater there and the scarifying teeth there. The repaving process looks something like this. This operation is moving to the left. This is the new hot mix asphalt in the truck. It dumps it in this hopper here, and it moves to the back of this piece of equipment. Down here are the scarifiers. Well, first of all, the heaters. The pavement is heated here, and then it's scarified after it's heated. And then there's some liquid applied here. There's a leveling blade here, and then a course of this material, the reclaimed material, is placed down, and then a second course is placed on top of that of hot mix asphalt. So in the repaving process, you heat the existing pavement, mix it up, put it down as a leveling course, and then put down new hot mix asphalt on top, all in one operation. That's what the repaving process is. And then you can see here, this new hot mix goes down here under this screed. It's a little bit different from the heater scarification. This is a picture of one. You can't see it real well. The operation is moving to the right, and the new hot mix comes in here and goes to the back, and that's the final thing that goes down. And in between, the existing pavement is heated, scarified, and put down as a leveling course. Now the remixing process is the third of these. This one here has some rather complicated looking equipment. This is just a preheating unit, all heaters. This is a second preheating unit. I don't know how many of them use 2 heating units, but we show them here. Here's a truck with new hot mix asphalt, which will be put in this hopper. And What happens here is this heat, again, this has a heater. This operation is moving to our left again. The hot mix asphalt goes here back to this place where it is mixed with the material that's picked up off the pavement. And in this case, the scarified material, heated scarified material, sometimes with an additive, is mixed with the new hot mix that came from the plant, and it's all put down in one course. And this is an actual surface course that's put down. Of course, the rollers come along behind that. So this is slightly different from the other two. And here's another remixing equipment in living color. You can see in this case, this operation is moving to the right. Here's the receiving hopper where the truck dumps the hot mix. The hot mix goes up here and goes into here. These are the heaters here. The scarifier digs up the existing pavement and somehow gets it to this pug mill where it's mixed with a new hot mix, and then all that material gets over here and is deposited on the pavement there in front of the auger and goes under the screed and is put down as one course. And here's a picture of that. It's pretty much of a monster, but you can get an idea of how that works. This is the paver hopper here, and the operation is moving to our right and this way. Here's the roller that's rolling the pavement that has come out of the machine. And this is what it looks like before and after. This is before the pavement was worked on, and this is the finished product here. So you can see there's a pretty decent improvement there. As far as the performance of hot in-place recycling, there's some variability in the service life depending on the type of operation that you have. Heater scarification, they say, will last 3 to 5 years. Repaving will last longer than that, probably 8 to 12 years. And on remixing, that age has not yet been established. Apparently there hasn't been enough projects and enough time to determine that. The existing pavement, though, needs to be at least 3 inches thick, and really it should be thicker than that if you're going to be going down. You would never want to take 2 inches off of a 3-inch pavement. You might want to take 1 inch off in hot in-place recycling of a 3-inch, but you need to leave at least 2 inches and probably more in place, or your pavement has a good chance of failing, because leaving a thin pavement like that just doesn't work real well. So you should have at least 3 inches and preferably more of hot mix before you do this operation. How about the cost of the recycling techniques? Cold in place recycling usually costs somewhere around 96 cents a square meter, but we're not dealing in metric units here, so we'll go over here, about 80 cents a square yard. If you go 3 inches deep, it costs about twice as much. Hot in place recycling, we're talking about going down about 1 inch into the existing pavement. The heater scarification method costs about 75 cents to $1.35 a square yard. And this was at the time that this information was gathered. That will change over the years, but this will give you a comparison between the different costs. Repaving is a little bit more expensive than heater scarification. And remixing is even a little bit more expensive yet. Now this repaving, I don't believe that includes the hot mix asphalt surface course, because if this costs less than this, then it can't possibly, I don't believe, include the hot mix asphalt course that's on top. Another type of operation is cold milling. Now that we've finished with cold in-place recycling and hot in-place recycling, cold milling has several different aspects. It includes the removal of the pavement surface, and it uses carbide cutting tips. Yesterday, John Reese spoke to you about the difference between carbide cutting tips and diamond grinding. These are the carbide cutting tips that cut into the existing pavement. It's normally done on asphalt pavement, not very often done on concrete pavement. The purpose of cold milling is to restore the profile of the pavement. It reestablishes surface friction. Primarily, it's used for removing a layer for recycling. Seems to be one of the biggest uses these days, and to prepare for an overlay. These two things here are what it's mostly used for. And in the same vein, it restores the profile before you do your actual resurfacing. This is what the surface looks like after milling, and it's not a very pleasant surface to drive on, you know, so normally an overlay is placed over milling. However, in some cases, it's left for traffic to run on. The performance and costs of cold milling. First of all, it is an integral part of many, in fact, most overlay projects and most recycling projects. A cold milled surface by itself is said to last 3 to 7 years, but that depends on the condition of the existing pavement and how the cold milling is done. The typical costs range anywhere from 50 cents a square yard to $3 a square yard, and most of them are down in the lower portion of that. So especially if you get a large milling operation, it's not too expensive. Next, we'll look at thin hot mix asphalt overlays as a form of pavement preservation. When we talk about thin hot mix asphalt overlays, we're talking about overlays that are about 3/4 to 1.5 inches in thickness. And it's plant mixed material made at a hot mix plant and delivered to the project, of course. We're going to talk about 3 kinds of hot mix asphalt overlays. First of all, dense graded, which is the most used of all the hot mix asphalt overlays. Open graded, which is the open graded friction course. And stone mastic asphalt, or sometimes called stone matrix asphalt, referred to as SMA. The purpose of these is very similar to the others: to restore rideability to the pavement and to improve the surface friction. Also, the open graded friction course reduces hydroplaning and tire splash. It's the only one that's made to do that particular function. We'll take a look at the gradations that are involved with these. First of all, dense graded is what we also call a well-graded material. There are all different sizes. There's large, intermediate, and small. All the different sizes are in there. When you compact that, it gives you a dense mixture. When we talk about open graded, most of the particles are pretty much the same size, and this leaves a lot more voids in the mix. And this is designed for water to go through when you have an open graded mix. And then there's a gap graded mix. This is what's used in stone mastic asphalt. In gap graded mix, you have material of one size. You may skip another size and then have more material of the next size, skip a size, and so forth. So there are more voids than in a dense graded mix, but not as many voids as in the open graded mix. The reason for the gap grading is to allow more space for asphalt. SMA has a higher asphalt content. It also contains cellulose fibers, and that is the gaps in there are necessary for that. It also gives you a coarse-looking mix when you have a gap-graded mix. Let's look at the performance of thin hot mix asphalt overlays. First of all, dense graded hot mix asphalt. It's widely varying service life anywhere from 5 to 12 years. And this depends a great deal on the condition of the existing pavement. I believe you all know that if you put an overlay over a poor pavement, that it's not going to last nearly as long as if you put it over one that's structurally sound. The pavement has to be in relatively good condition. An open graded friction course is said to last 8 to 12 years. However, an open graded friction course may be more susceptible to stripping. Stripping is the separation of the aggregate from the mix, where the asphalt doesn't hold it anymore and the aggregate strips away. Many agencies have had trouble with this. The state of Kentucky used to put open graded friction course over all their interstate highways, and they had considerable trouble with stripping, so they did away with that. However, many agencies here in Ohio have used open graded friction course, and it's been very successful. So it depends a lot on the type of aggregate that you have and the way that you make the mix. It could depend also on the type of asphalt that you use. So there are varying effects as far as open graded friction course. It has been successful for some people and not so successful for others. Stone mastic asphalt, there's no long-term performance data on that. The short-term results, however, show that it does do a better job than regular hot mix asphalt that we used to have anyway. And that is an resistance to cracking and rutting. In fact, that was what SMA was originally designed to do, to reduce cracking and rutting. And we'll see a little bit more about that here in a few minutes. Let's talk first about dense graded thin hot mix asphalt overlays. This is what's used in preventive maintenance, the thin overlay, which is, again, normally from 3/4 of an inch to 1.5 inches, or from 1 inch to 1.5 inches, normally. You need to select the proper course thickness. Anytime that an agency has to do an overlay, one of the things that has to be done is to select the proper thickness of the overlay. You're going to put down a 1-inch overlay, 1.25 inches, 1.5 inches, or thicker or less than that. When we're talking about thin hot mix asphalt overlays, the range is between 1 inch and 1.5 inches. What do we base that decision on? The existing pavement condition. If it's in relatively good condition and smooth, you can probably put down a 1-inch overlay and get a good job, and it'll last a long time. If the pavement is not in very good condition, you may have to go to a thicker overlay. And also, how long do you want the pavement to last? How long do you want that overlay to last? The thicker overlay will normally last longer, up to a certain point. And your available funds. This may override the other two, and in most agencies it does. How thick the overlay can be will depend on your financial condition in many cases. You need to select the proper mix type. There are a lot of mix types. We'll talk a little bit more about those in a little while. The mix type is based on the amount of traffic. For light traffic, you may have one kind of mix. For heavier traffic, you use a heavy-duty mix. And the type of mix also has to be correct for the course thickness. If you're putting down a 1-inch overlay, you wouldn't want to use aggregate that's 1-inch maximum size. You have to select the mix for the proper thickness. High stress areas are a little bit different. There are mixes designed specifically for high stress areas. We'll talk about one or two of those here in just a little while. Let's look first at conventional hot mix asphalt types. There's the ODOT spec 446, 448 type 1. That's similar to 404. And you'll notice that I didn't actually say anything about 404 because ODOT doesn't use 404 anymore. Most of the other agencies do. How many agencies here use the 404 spec? Most of you do. Okay. The 404 spec is still in this red spec book, but when the next one comes out, it's not supposed to be in there. So hang on to your old spec books if you're going to use 404. But ODOT has done away with the 404 spec. They haven't been using it for several years, and now it's not going to be in the next spec book. But this 446 and 448 type 1 is very similar in gradation to that. The only difference is in the way that the quality control is performed. And we won't get into that, but that's primarily the difference. We believe we're getting a better product here in Ohio from 446 and 448, and that's why they have gone to that from the old 404. Normally this course is placed 1 inch to 1.5 inches thick. ODOT traditionally does it 1.25 inches. It's a 1/2 inch maximum size aggregate using number 8s and sand in the mix. It's for light and medium traffic. It's not a heavy-duty mix. And normally we use PG 64-22 asphalt binder. Now this is the first time I think I've given you a designation for an asphalt binder, and we'll say a few words at the end of this about the new SuperPave method for designating binders and mixes. But this is an asphalt binder very similar to AC-20, the old AC-20 asphalt cement. And we use the term asphalt binder because the mix or the material, the asphalt, can be either modified or unmodified asphalt cement. So depending on what is called for in the terminology of the binder, and so we don't use the term asphalt cement when we identify this in the SuperPave system. We use the term asphalt binder. There's also ODOT spec 448 and 448 type 1H, and the H stands for heavy duty. This is a heavy duty mix. It's 1.5 inches minimum. It can be put down 1 3/4, 2 inches, up to a maximum of 2.5. ODOT normally uses 1.5 inches, sometimes 1 3/4. This has a little bit larger size aggregate, 3/4 inch maximum size aggregate, and it's designed for heavier traffic, for heavier vehicles and for more vehicles. It's also used for moderate high stress applications. If you have something that's a little higher stress than normal but not real high stress, type 1H can do the job for you. The ODOT specs now call for PG 70-22M polymer modified asphalt binder to be used every time you use type 1H. Now PG 70-22 is a polymer modified, the M means modified, polymer modified asphalt that has stronger characteristics than the PG 64-22. The 70 means that it will resist rutting and higher temperatures more than the PG 64-22. There are also some specialty type hot mix asphalt mixes, and we'll look at those. First of all, we have polymer modified asphalt concrete, which ODOT has in a spec that is just really in the draft stages right now, SS 854. And this is primarily for preventive maintenance, thin overlays. It's specifically designed for that. This overlay is normally placed 3/4 of an inch to 1 inch thick. So you see it's a little bit thinner than the normal hot mix asphalt overlay. And in order to do that, it will have to have finer aggregate, and it does. It has considerably finer aggregate. The Type A is quite fine. It's pretty much a sand mix for medium traffic and for urban use. The Type B is what's normally used. It's been dubbed smooth seal. Somebody gave it that name, I don't know who. It's for all applications, and it can be for heavy-duty use as well as high-speed use. The PG 70-22M and PG 76-22M, 76 being even more resistant to deformation, asphalt binders are used in this. The SS 854 actually calls for this, 76-22, but some of the earlier versions of this, I believe the PG 70-22 also was allowed. Some more specialty type hot mix asphalt, the open graded friction course. This is a thin surface course, we mentioned it before. It provides high friction and it reduces splash and hydroplaning. Have any of the agencies here used the open graded friction course on any of their pavements? You have not. Most townships and counties don't use it a whole lot, although I'm sure there are some that probably have tried it out. It's a uniformly graded mix. Remember, most of the particles are about the same size, and it produces high air voids. And those air voids are what allow the water to go into the course, and then when it hits the pavement below, the impervious pavement below, the water flows out to the sides and goes away from the actual area where the traffic is. You need a crushed aggregate, a good crushed aggregate with rough texture. And then, of course, there will be a higher asphalt content here in order to hold the particles together since you don't have fines in it. And that also the thicker asphalt coating will make the particles adhere to the mix better and reduce the stripping. Normally, this is placed 5/8 of an inch to an inch thick for your surface course, with many of them being about 3/4 of an inch. There are also some hot mix asphalt types for heavy traffic and high stress. One of them is SMA, stone matrix or stone mastic asphalt. ODOT has a spec on this now, supplemental spec 856, and these are on the internet. If you want to get these, you can either contact ODOT if you want to, or just go to the internet and get them, download them off of there. This is a gap graded material. Remember, we defined what gap graded was before. The maximum particle size is 3/4 of an inch. This is for a surface course. Remember, the normal surface course for 404 is a 1/2 inch maximum size. So this has a little bit larger size aggregate than a normal 404 surface course. We have cellulose or, fibers or plastic additive or polymer modified asphalt binder to increase the ability to hold asphalt in this particular mix. Superpave is another heavy traffic and high stress material. ODOT has a spec on that, SS 858. There are quite a few mixes on that, and we'll talk about all the different mixes on that in just a little while. But just in general, for preventive maintenance, we have what we call the 9.5 millimeter nominal size mix, and this is placed 1.25 inches thick. Well, a 9.5 millimeter nominal size has 1/2 inch maximum size aggregate. This is almost identical to 404, or very similar to 404. The nominal size is one size smaller than the maximum particle size. If you have a 9.5 millimeter nominal size in super pave, the maximum size is 12.5 millimeters. What is that in inches? 12.5 millimeters. Anybody remember? That's a half inch. 12.5 millimeters is half an inch. So half-inch maximum size, placed 1.25 inches thick for heavy traffic and high-stress areas. But primarily for the most high-stressed areas, we have the 12.5 millimeter nominal size, which has a maximum size of 19 millimeters, which is 3/4 of an inch. And this is placed 1.5 inches thick. This is very similar to the type 1H mix. Okay. And with super pave, we use PG 70-22M asphalt binder. That's what's called for in the ODOT specs now. Now this may be more than what your agency needs, but it's a good idea to know about these. These can be used in intersections or any other high-stress areas that you might have, places where turning traffic or stopping and starting traffic is causing problems. The cost of thin hot mix asphalt overlays for dense graded, this is an idea of what it was about whenever this material was gathered, $31 to $38 a ton, which translates into about $1.70 to $2.20 per square yard. I went through the ODOT contracts awarded in 2000, and the cost varied from $1.70 to $2.15 a square yard last year for ODOT. So this is pretty close to what it was last year. Of course, that was for large projects, so it's going to vary somewhat. For smaller projects, you won't get as good a price. Open graded friction course, $43 to $44 a ton, translates into about $1.25 to $1.42 per square yard. Now you notice this is more expensive per ton than hot mix, but less expensive per square yard. And why is that? How can that be?
Thinner layer.
Thinner layer. There you go. Somebody's awake. Okay, I'm glad to see that. Thinner layer, that's right. Thinner layer, so per square yard it costs less. Stone mastic asphalt is normally about 20 to 40% greater than dense graded hot mix asphalt. It has a higher asphalt content, has some extra additives, special aggregate, so it's more expensive, going to be more expensive than a hot mix asphalt. Let's look now at some of the newer technologies. What we've talked about so far are the things that ODOT has used. Maybe you haven't used anything but the hot mix asphalt overlays in the past, but there's a couple of new things here. One of them is called the ultra-thin friction course, and another one is called macro surfacing. The ultra-thin friction course is a gap-graded polymer-modified hot mix asphalt placed on a heavy polymer-modified emulsified asphalt tack coat. Try to say that in one breath. Okay. Well, let's take a look at it and see what it really means. It's a gap-graded mix. Remember what gap-graded was? We have higher voids than in a normal dense-graded mix. We have a polymer-modified asphalt that's used to hold that mix together, because it's a polymer-modified hot mix asphalt. It's placed on a heavier than normal tack coat, more material than normal, polymer-modified emulsion. Now, tack coat is normally an asphalt emulsion, but this emulsion is polymer-modified, and it's heavier than a normal tack coat. So that's what we're looking at. That's what this ultra-thin friction course is. The thickness normally is 10 to 20 millimeters, according to the information here. 0.4, that's 0.4 to 0.8 inches. But from what I understand, it's normally placed about 3/4 of an inch thick. That's what they've been using. The benefits of it are corrects surface distress and improves the ride. Of course, it has to be on a fairly decent existing pavement because it's only 3/4 of an inch, and 3/4 of an inch will only correct so much. It reduces noise by its surface texture. It increases surface friction, again by that texture, and reduces splash somewhat. It's marketed in the United States as Nova Chip by Coke Pavement Solutions. It's been around this country. It originated in France. It's been in the U.S. for about 10 years or so. In Ohio, this is about the 4th season they've been using Nova Chip. It's been done on several projects, I think about 17 projects in Ohio, if I remember right. This is what the machine looks like. This is the hot mix asphalt truck dumping the mix in here, and then here the material comes out. There's a spray bar here that sprays the emulsion, and then there's a place where the hot mix asphalt comes out, an auger where the hot mix asphalt is distributed. This is a drawing of the material. This says 3/8 nominal mix size. It's not exactly accurate because it's usually just a slightly larger than that. But this is for 3/8 nominal size. The total depth of this mix here is 9/16 of an inch. But normally now in Ohio they're using 3/4 of an inch, which would be 12/16 of an inch. So similar to what this is, but just a little bit thicker. And there's a good thick coating of asphalt on the aggregates. This is the asphalt emulsion tack coat, which is called Nova Bond, that is extra thick. It's placed at a thicker than most tack coats that are done in with regular hot mix asphalt overlays. That's the method that they use. Let's take a look at the application rates. The emulsion is applied at 0.15 to 0.3 gallons per square yard, and you can see that's greater than what we normally put down on our tack coat. The ultra-thin hot mix asphalt overlay in the initial literature, and this is the information I have, there's a type A, a type B, and a type C. They use here in Ohio what they call type B, but it actually is a little bit thicker than this, and it comes out to about 80 pounds per square yard. And 3/4 inch thickness comes out to about 80 pounds per square yard. So these are a little bit shy. This is the original information that came from Coke Asphalt, and that's been revised slightly. At least in Ohio it has. So the total thickness was designed to be 3/8 to 3/4. It's being put down at about 3/4. Here's a close-up of the Nova Chip process. The process is going to the right. This is the emulsion being put down. You can almost see it, and this is the hot mix. Let's take a closer look at it. Here is the emulsion, the Nova Bond emulsion right there. It's being sprayed, and that's hard to see. I don't know if you can see any better there. Can you see that, the brown color in there now? It's sprayed here, and it's down here, and then the hot mix asphalt is up there. So this is the pavement before the material's put down. It's sprayed. You can see the brown emulsion here, and then the hot mix asphalt this is the auger here, and the hot mix asphalt is coming out there. So it's very, very close. The hot mix is very close behind the actual tack coat. So it's different in that respect. And this is what it looks like when it comes out of the paver. You can see it's a coarse-looking texture. Now let's take a look at macro surfacing. This is also called armor coat. Road armor. I can never get that right. Road armor. It's also called that. I don't know why, but they had to dream up some kind of a name. This also comes from Koch Pavement Solutions. The components of this are an extremely fast-setting asphalt emulsion, highly polymer modified, and then a single-size stone. This is similar to a chip seal, or basically is a chip seal, and this stone is between 3/8 of an inch and number 4 screen. Now, about how big is the number 4 screen? Anybody remember? It's just slightly less than 1/4 of an inch. So most of the aggregate is between 3/8 of an inch and about 1/4 of an inch. So pretty much all single-size aggregate. And that's the best type of aggregate for a chip seal. There's consistent application of the materials by a single machine instead of having one with the emulsion and another machine for the aggregate. It's all in one machine in this case, and we'll see that a little better in a moment. It's a continuous process. The aggregate is fed to the machine and the emulsion is fed to the machine, and it just keeps moving. It'll correct minor surface distresses just like a chip seal. You can only do so much with one layer of stone, with asphalt emulsion and one layer of stone. It does a good job of waterproofing and filling in small defects. It requires a good existing pavement structure. You can't put it over anything that's in poor condition or failing, just like any other chip seal. Here's a look at chip seal versus macro surfacing. You can see the difference in the operations. In the conventional chip seal, the distributor distributes the asphalt emulsion, and then the spreader comes along and sprays the aggregate, and then the roller follows up closely, and then usually sometime the next day or so the broom comes along and sweeps that off once the emulsion has set. Depending on how quickly that emulsion sets, and with a normal rapid setting emulsion, we've always been told that you should wait until the next morning normally to do the sweeping. With macro surfacing, they have a polymer modified emulsion and the aggregate that's spread in the same operation. The aggregate immediately behind the asphalt emulsion. The roller comes along and rolls it, and it's said that in an hour or less you can sweep that off and it's ready for traffic because of the highly polymer modified emulsion. It sets so much faster than normal. And here's a close-up of the equipment. This is the emulsion spray bar, the aggregate spreader, and you can see that in the operation that's going to the right, here's the emulsion and here's the aggregate right behind that. And when we teach chip seals, we always talk about how important it is to have the aggregate right behind close to the emulsion. This one really has it close. This is what the finished product looks like, a macro surfaced lane there. I don't know where that is, but you can see the texture of it there. As far as cost is concerned, macro surfacing costs more than polymer modified chip seal and conventional chip seal, but less than microsurfacing and the thin lift hot mix asphalt. Well, so much for preventive maintenance. Now let's take a look at pavement rehabilitation. That's also a part of pavement preservation. Pavement rehabilitation includes thicker one-course overlays. If you want to put down something thicker than 1.5 inches, remember when we were talking about preventive maintenance, we said up to about 1.5 inches. So anything more than that, you would consider a pavement rehabilitation job. Or multi-course overlays are considered to be pavement rehabilitation. Again, this is all part of pavement preservation. We're just differentiating between these two. Pavement rehabilitation also includes milling and overlay or an inlay. And by an inlay we mean when we mill out and leave pavement on each side that's the original elevation and just pave in between those and bring the new pavement up to the level of the existing pavement. That's what we refer to as an inlay. And that can be done either for 2 lanes of a 2-lane pavement or maybe just a single lane. Sometimes only one lane needs to be improved, and milling and an inlay can solve that problem. It also includes milling and recycling with an overlay or surface treatment. So the combination of milling and recycling can be plant recycling possibly, and then putting in an overlay to bring it up to the existing existing elevation, and maybe then even another overlay over that if need be, depending on whether it's a minor or major rehabilitation project. Remember, pavement preservation only includes minor rehabilitation projects. Here's a look at a rehabilitation project, but this is a major pavement rehabilitation project, and this is not a part of pavement preservation. This is rubbleizing and with a thick asphalt overlay. This type of project is not part of pavement preservation. Well, let's take a look at pavement preservation briefly. Again, this is the sum of all activities that are undertaken to provide and maintain serviceable roadways, taking care of your pavement. It includes the following: routine maintenance, preventive maintenance, and minor pavement rehabilitation projects. And what does it exclude? It excludes new construction or reconstruction and major pavement rehabilitation projects. In summary, now that the great part of the new construction boom is over, preservation of our system is really essential. The federal government has recognized this, and they have provided funding in the latest plan. The T21 provides funding for preventive maintenance, and also guidance from the Federal Highway Administration. They have come out with a lot of information on preventive maintenance, pavement preservation. They've published manuals on it. They have seminars on it. They have videos on it. And I guess they're also putting money or making money available for agencies for this. I don't know what the procedures are for an agency to get the money, but the word is that federal aid is available for this. The value of pavement preservation has to be imparted to all agencies. You folks that are here are aware of it. Probably there are some agencies that are not aware of the value of it. And also to the traveling public. Many people do not realize what preventive maintenance and pavement preservation entails, as one of the presenters was telling you yesterday. The key to a successful pavement preservation is the implementation of certain concepts. And let's take a look at what some of these keys are. First of all, in order to do this properly, you have to establish simple, measurable goals. And by simple, we mean goals that are obtainable. Simple, obtainable, measurable goals. Then you need to document the benefits, the programs that you do and the research that you do. Keep track of that. In any preventive maintenance or pavement preservation program, you have to have good records, not just keep it in your head. You need to promote those benefits. Let people know. Let the traveling public, let other agencies, let the government agencies know. And you need to obtain dedicated funding. I believe this was mentioned yesterday, but dedicated funding means funding that goes only for this preventive maintenance or pavement preservation program and cannot be siphoned off for anything else. Now, this is difficult to do in many agencies, I'm sure, because they probably don't have enough money. Not only dedicated funding, but that has to be initially higher than the rest of the funding in order to overcome that worst first obstacle. you need to have this funding be greater at the beginning and then taper off. That is very difficult to obtain, and it takes a concerted education effort on the part of the people that hold the purse strings. You need to develop guidelines for implementing these programs and then follow those guidelines, improve the application of available treatments, improve the way you do your treatments, develop and implement innovative procedures. Many agencies have come up with innovative procedures for preventive maintenance. It's good to identify who the leaders are in preventive maintenance, people that have been successful with it, find out who they are, find out what they're doing, and then learn from them and use that in your own system, and obtain the support of top management. If you don't do that in any agency, you certainly will not succeed. I want to thank you for your attention on this, and I wonder if there are any questions on pavement preservation before we talk a little bit about another topic. Any questions on pavement preservation?
For open graded mixes, do you have references on who in Central or Northern Ohio is using open graded mixes?
Open graded friction cores. I believe ODOT District 4 is using it. What you could do, what I would recommend if you're interested in that, is call ODOT. Call the construction. You can call the construction bureau, construction office, and see if they can guide you to that. Yeah, Bill Christensen is in the construction office. Yeah, there's a name for you. Bill Christensen could help you. And if I can talk to you at the break and see if maybe I can think of something else that might give you some information on that. Any other questions or comments? Let's take a quick look now at SuperPave. I mentioned this. This is the new asphalt technology. SuperPave is an acronym for Superior Performing Asphalt Pavements. And some of you may have heard of it, but many of you probably don't know a whole lot about it. Anybody here that is familiar with SuperPave from one of the agencies? You haven't used it in the townships yet, have you? How about the counties? Who are the county representatives? Have you used it in your county? You have not yet.
Seen it used in the county on state routes.
Okay. Pretty much the state is the only one that's using SuperPave right now. There are a few counties that have used it, but there are 88 different counties, and out of those 88, there's probably only a very few that have used it. But here's a quick look at it in the remaining minutes. SuperPave is a system. It's a product of the Strategic Highway Research Program that took place from 1988 to 1993. It was a 5-year program. They spent about $150 million, $50 million of it on asphalt. And from that came a new asphalt binder specification that we've already mentioned, new test procedures also for the binder, stricter procedures to try to improve the performance of the asphalt binder. And they use what we call performance grades. Also from that came a new asphalt mixture design system. New mix design system, and this uses the gyratory compactor. Most of you may not be familiar with mix design, but in the old mix design system, they used a hammer to make the test specimens. In this case, we use a gyratory compactor to make the test specimens. It also has a mixture analysis and pavement performance prediction system. Those are still in the works. They hope that they'll be able to predict the life of a pavement from different type mixes. And there's also a system software for selecting the proper binder and for doing the mix design. Those are still, the binder one is out, but the one for the mix is still in the works. The asphalt binder specification is a grading system based on climate. First of all, this grade here is the one most used probably in Ohio, PG 64-22. Very similar to the former AC 20. The PG stands for performance grade. The 64 is the average 7-day maximum temperature in degrees Celsius that this material should withstand. Now, 64 degrees Celsius is 147 degrees Fahrenheit. That's pretty high temperature, and that's normally what we've been designing for. The minus 22 is the minimum design temperature that it should stand to protect against cracking of the pavements. This high temperature is designed to protect against rutting and other pavement defects, such as that, rutting and shoving. And the low temperature designation is designed to protect against low temperature cracking. Here are some common asphalt binder grades, and all of the major oil refineries in this area went to this system in 1997. So any asphalt material that you get will be in these designations. PG 64-22 is the most common, similar to AC 20. PG 64-28, you see, has a lower or a greater low grade, higher low grade. That means that it will protect to a lower temperature. It's more resistant to a low temperature cracking than the PG 64-22. It's specified in ODOT for their intermediate courses. PG 58-28 is not as resistant to high temperatures, but is resistant to this extent to low temperatures, to minus 28. Incidentally, minus 22 is about 8 degrees below zero. PG 58-28 is similar to the old AC 10. There's a PG 70-22. The 70 means it's more resistant to higher temperatures, and it's also more resistant to heavy traffic. The PG 70-22M is polymer modified, and it's used in the Type 1H mix. It's required in the Type 1H mix. That's the heavy-duty mix. It's a better performing asphalt than the PG 64-22. And the 76-22M is for high stress areas. This is even more resistant to rutting. These are the super pave mixtures, and you have it there in your handout. There are 5 different sizes in super pave. This is the size designation. It's a nominal size. It's one size smaller than the maximum aggregate size in every case. You can see that. This is 3/8, that's a half. This is a half, that's 3/4. This is 3/4, that's an inch. These are the uses. The 9.5 millimeter mix is used for surface. The 12.5 is used for heavy traffic surface. This is used for intermediate. The 1 inch or 25 millimeter is used for base. This is very similar to the old 301, and the 37.5 millimeter is used also for base, and this is very similar to the 302 large asphalt, a large stone base. Oh, wait a minute, let me go back and see one more thing. These are the normal course thicknesses, and you can see surface course, and here heavy traffic, and here the base courses. So that's a look at the different super pave type mixes. Any questions now on either super pave or pavement preservation? We've still got 4 minutes. Yes.
The PG grading system is on the FHWA website, and you can download it and play with it and decide which is the best binder for your area. It's based on like 2,000 weather stations programmed into the system. It's got like 50 years of weather records in it, and it chooses the best binder for your area. Although it's pretty much standardized, and you showed the common list of PG binders that are generally
Right.
used. But
Right.
it's all you know. It's something that you can download and become familiar with how it was all developed. If you're interested in it.
Okay, and that's on the FHWA website, which is www.fhwa.gov.
I believe it is.
I think that's it.
It's LTAP, Long-Term Pavement Performance Bind, BIND, the binder.
Okay.
Look for that. And
That's within the homepage of that, though.
you'll be
Okay.
able to download
There's a lot of good information nowadays on the internet. The problem is finding it. Yeah. Any other questions or comments on, yes?
I'm not sure I'll ask the question right, but on the graph that we keep seeing, is there any data that somebody's put together, say like for an average, you take a road that you go out on a fairly good road and go out and crack seal, how much that's improved the life, or how long that will improve the life of your average road and the cost benefit that you'll get from it?
Someone's going to cover crack sealing today. Would you be able to answer that when you get to your presentation?
Yeah, I take care of that in crack sealing.
Okay.
And crack sealing was just an example. I'm looking
Okay.
at all of them, like chip seal or any others that we might.
I think that's so variable that you can't really assign anything except a range in years of what it will do. We know that it'll extend the life of the pavement, but how much is going to depend on so many things: the condition of the existing pavement, what product you used, how well it was put down, the weather conditions. All of those things are going to affect how much life that adds to your pavement. About the only thing you can do is keep track of that within your agency and see what different ones do for you. And you have to keep track of all those conditions, because those all affect your end product. So I can't really give you a good answer to that. And that graph specifically doesn't have years or on that for the time, because it's so variable. Yes.
The management program that Joe was showing yesterday.
Yes.
He said if you get your streets in there and you constantly monitor them over the years, you can see how long your protocols extend the life of your pavement compared to what you've done in the past.
Right. If you keep track of it within your agency, you can see that. Yes.
I was just looking for something. I mean, I don't want to reinvent the wheel. If it's, if somebody's got something that they know is the best way to approach a road that, you can build on preservation, why not use that versus trying to collect a bunch of data and then going back and reevaluating it maybe 10, 15 years down the road by then.
Okay.
If we don't have any.
You're looking for specific guidelines? Okay. If after this other presentation you still have problems, we'll have a panel at the end of the day, and maybe we can put all of that together and hopefully answer your question a little bit better at that time. That's a very good point, and it is quite variable. Just about 10:30. I think most people are probably looking to have a cup of coffee or drink or something. If there are no further questions, then we will go to the break. And don't forget, there's some catalogs and some books back there that you can look at if you wish. Thanks very much.